Hello students, this is Professor Chalai, and in this video we're going to look at acid-base reactions. By the end of this video, you should be able to identify acids and bases and identify acid-base reactions and be able to write their complete and net ionic equations. Let's get into it. And to start, let's look at a simple reaction between two ionic compounds, HCl, hydrochloric acid, and NaOH, sodium hydroxide. Now, if we were to write the balanced chemical equation for this, we know that HCl breaks apart into H plus and Cl minus, whereas NaOH breaks apart into Na plus and OH minus. And so if you were to have a double displacement reaction, so that's where the ions exchange, we'll have, let's start with the Na ion from the sodium. So before we write the products, let's write the reactants. So we have HCl aqueous plus NaOH aqueous reacting. And just because these are two different things, I want to use two different colors. Okay. So in one case, we'll have the Na from NaOH combining with the Cl minus from HCl to give us NaCl, that's aqueous, and we'll have the hydrogen from HCl, so hydrogen, and the OH from NaOH minus to give us HOH, or really this compound is just water, H2O. So let's rewrite that as H2O, which we know is a liquid. This here, and this equation is already balanced, this here is an acid-base reaction. We have an acid and a base, and we'll look at what the definitions of acids and bases are, forming an ionic compound, a salt, and water. And so if we were to write the complete and net ionic equations for this reaction, this is what we'll get. So HCl aqueous breaks apart into H plus aqueous plus Cl minus aqueous. NaOH breaks apart into Na plus aqueous plus OH minus aqueous, and all this goes to give us NaCl aqueous, so that breaks apart into Na plus aqueous plus Cl minus aqueous, and then H2O is a liquid, so we do not break that apart. Alright, so that's the complete ionic equation. For the net ionic equation, we eliminate everything that stays the same, like Na plus and Cl minus. And so all that we're left with is H plus aqueous plus OH minus aqueous, going to give us H2O, liquid. So I mentioned this is an acid-base reaction, but so what is an acid? Well, let's look at HCl. When it breaks apart into H plus and Cl minus, and that is the Arrhenius definition of an acid. It is anything that produces H plus ions when dissolved. And similarly, if we look at this NaOH base, when it dissolves, it produces Na plus and OH minus. And so for the Arrhenius definition of a base is any substance that produces OH minus when dissolved. So those are definitions of an acid and base. But really, I write H plus plus Cl minus here. What happens when HCl dissolves, so HCl aqueous, when it dissolves, we said it reacts with H plus, it reacts to form H plus ions, and then whatever other anions left over. But really, in all of this case, this is being dissolved in water, right? So there's always going to be water present. And because H plus has 1 proton, 0 electrons, and typically 0 neutrons, it's difficult for just a single proton to be floating around in water. So what happened is this proton will attach itself to a water molecule, and what we'll end up having is this H3O plus combination molecule, compound, and then Cl minus left over as well. And this is what we call a hydronium ion. Hydro from water, hydronium ion. So hydronium ion is basically H3O plus ion formed when acids dissociate or break apart into H plus, and it's formed from H plus. Okay, so that anything that forms H plus is an acid, and in this example we used HCl and it produced 1 mole of H plus ions for every 1 mole of HCl. But polyprotic acid, poly means more than one, protic comes from the word proton, which is just an H plus, is any acid that produces more than 1 mole of H plus ions or H3O plus ions, hydronium ions, per mole of acid dissolved. An example might be something like sulfuric acid, right? Sulfuric acid is H2SO4. When this dissolves, it produces 2 H pluses for every 1 mole of H2SO4. SO4 2 minus aqueous. So that's an example of a polyprotic acid. Usually there are going to be more than one H plus that can dissolve. And the H plus, the protons that can dissociate are usually written before the rest of the compound. So that's a polyprotic acid. Now let's look at strong and weak acids and bases. So a strong acid is something that when you dissolve it in solution, it completely dissolves and breaks apart. So strong, there we go, strong acid or base is a substance that completely dissociates. So for example, a strong base is NaOH because when you dissolve it in water, it completely separates into Na plus ions and OH minus ions. A weak acid or base, on the other hand, as you might expect, is a substance that does not completely dissociate. Examples of these might be acetic acid. So acetic acid has formula HCH3COO. And so when this dissociates, it doesn't completely separate into H plus and the remainder is acetate ion. So instead of writing a strong arrow going to the right, sometimes people do 2 half arrows to say that it doesn't completely form these guys. Some of the molecule is still left over, completely bound. Some molecules still have their hydrogen, their proton held strongly by the molecule, and it doesn't want to let it go. Whereas some molecules let that H plus go to be used in reactions. So those are definitions of strong and weak acids and bases. And so you will think that an acid-base reaction, sometimes called a neutralization reaction, is simply any reaction where the hydronium ion, or the H plus from the acid, and the OH minus from the base combines to form water. So reaction to form salt and water, and usually it's the H plus aqueous plus OH minus aqueous going to give us H2O, and then whatever salt is left over. So this is usually typically the net ionic equation for most acid-base reactions. Sometimes we will see people write it this way, H3O plus, because instead of H plus we actually technically have hydronium ions floating around, so that aqueous plus OH minus aqueous to give us 2 H2Os. So this again is usually the net ionic equation for most acid-base reactions. Alright, so with that, with our understanding of what acids and bases are, For these reactions, hydrobromic acid and barium hydroxide, write the balanced chemical equation and the complete and net ionic equations for the reaction. Do that, answer number questions 15 and 16 by yourselves, and then on pause the video and we'll go over them together. Okay, let's look at hydrobromic acid. So HBr aqueous plus barium hydroxide BaOH2 aqueous. This is an acid-base reaction because hydrobromic acid is an acid, has H+. Barium hydroxide is a base, it has OH-. So you will think that the barium, which has a charge of Ba2+, will combine with the Br- to form barium bromide. So BaBr2, right, to make sure that the charges are balanced. And then here we have OH- with two of them and H+. We need two of them to form 2H2O liquid. So I multiply the bromine by 2 on the left and right hand sides, and that ends up balancing the equation completely. Okay, so that's our balanced chemical equation for this reaction. Let's look at the complete ionic equation. Hydrobromic acid, that's aqueous, so we'll break that apart. We get 2H+ aqueous plus 2Br- aqueous. Barium hydroxide is aqueous, so we'll get Ba2+ aqueous plus 2 hydroxides, 2OH- aqueous. On the right hand side, we'll get Ba2+ aqueous plus 2Br- aqueous. And this is water, it's a liquid, so we do not break it apart, we keep it together, so we get 2H2O. Alright, so let's look at what stays the same and what changes. Bromine, bromide, barium, all stay the same. So what we end up with is what we expected. We have 2H+, 2H+ aqueous, plus 2OH-, 2OH- aqueous, going to give us 2 water. And because all of the numbers are 2, we can just simplify that by removing the 2's. And like I've said earlier, pretty much all acid-base reaction will have this as the net ionic equation. All right, let's look at number 16. If you haven't worked it yet, please pause the video now and we'll go over it together. So we have in 16A, we have the weak acid hydrogen hypochlorite reacting with water. So hydrogen hypochlorite. So if you remember from our formula, hypochlorite has a formula ClO-. So hydrogen hypochlorite or hypochlorous acid has formula HClO aqueous. And if it reacts with water, H2O, I mentioned earlier that it forms water with the acid, will form a hydronium ion aqueous, and then the anion will be left over, ClO- aqueous. But because this is a weak acid, we're going to put double arrows. All right, let's look at B. So in B, we have a solution of barium hydroxide. So barium has a charge of 2+, hydroxide has a charge of 1-, so we need 2 of the hydroxides. And I'll erase the 2+ because it's not part of the compound when it's together. So we have barium hydroxide, and it says it's neutralized with nitric acid. Nitric acid, if we remember from naming acids, comes from nitrate, which has formula NO3-. So to balance that, we put 1H+, and so that is the formula. Hang on, let's just delete the minus sign, and that would be the formula for nitric acid. So that's right, nitric acid aqueous, and let's see what happens. So the barium and the nitrate will combine. Nitrate has a charge of -1, barium has a charge of +2, so we will have BaNO3 2 to balance out the charges. And since we needed 2 nitrates, we'll have to make this whole thing 2. Okay, now we have 2 OH-, 2 H+, which will form 2 H2Os. So this is the solution of barium hydroxide neutralized with the solution of nitric acid. And This is the answer for part B. Okay, we'll do a lot more, or in case you've done the acid-base titration labs in the first week, you probably already did a lot more calculations involving acids and bases reactions. In the next video, we'll talk about oxidation reduction reactions very briefly. I'll see you then. Bye.